Hello, Mr. Crommelin. My name is Hope Disney. Hi.
Nice to meet
Nice
you.
to meet you.
Hello.
I was just wondering if it would be okay if we asked you a couple of interview questions. And I really love your mustache, by the way.
Thank
It's
you.
very nice,
I've been
very
working
nice.
on it.
So, can you tell all of us your name and tell us a little bit about your project, please?
Well, I'm Andrew Crommelin, and my project was basically we were going to observe the solar eclipse on May 29th, 1919, and we were concerned with the celestial bodies surrounding the sun and their positions in space.
Okay, awesome. So, what were you guys trying to do or find in this project?
So basically, we were delving into the locations of stars and other celestial bodies beside our sun, and about how the sun itself would cause bending of light around it by this phenomenon that Einstein actually thought of called gravitational lensing. And the way that this would work is the universe has this fabric called space-time, and massive objects correspond to massive amounts of energy, and these would actually put divots into space-time, and as light would come close to that divot, it would actually curve and bend around these massive objects because of the dent that they put into space-time. And we were trying to prove this from this solar eclipse because you can actually see the celestial bodies around the sun when it's completely covered by the moon. Does that make sense?
Yes, it does. That's very fascinating. Thank you. So, where did the project or experiment occur?
Well, there were actually two places where this project occurred. I led a group to Sobral, Brazil, and I went there, and then my partner, Sir Arthur Eddington, led a group on the island of Principe on the other side of the Atlantic Ocean. So say if something were to happen, we would have two sources of this eclipse so that we could view it hopefully better.
That was very smart. Smart plan of you all.
Oh, thank you.
So, what other significant events were happening around the world at the time of the experiment?
So, right before this experiment, about 6 months before, there was a giant war in the world. It was called World War One.
I've heard of it.
It was pretty insane, yeah. And that just ended about 6 months ago. But in the world of physics, let's bring this all home here. In the world of physics, there were like three main events, and something called the International Astronomical Union was developed. And this was basically a union of all of these professional astronomers that were leading the charge into space and on ideas of space. And so we established this just so that we wouldn't have to go into space alone. We wouldn't have to bounce our ideas off of our own self. We were working in groups, and when you work in groups, you have better outcomes. Also, Arnold Sommerfeld and Walter Kossel released their displacement law, and James Jeans also released his dynamical constants of motion for the elements. So the physics of the smallest pieces of matter were starting to come into place. And this was a groundbreaking time in physics, the year of 1919.
Sounds like quite the year.
I know. A great time to be alive.
Sounds like it. So, who else was involved in the project? I know you mentioned some other people, but who else?
Well, other than myself, Andrew Crommelin, and my partner, Sir Arthur Eddington, I worked with a guy, his name was Charles Davidson, and he came along with me and my crew to Brazil, and he basically helped me run things. And on Sir Arthur Eddington's side, he had a guy who helped him, and his name was Sir Frank Watson Dyson. And all of us together kind of led the charge of this astronomical, groundbreaking observation.
Awesome. So what was your role in the project?
My role of the project was basically to lead my group and kind of give them direction in what to do with this. I led observations and making measurements with the stars from their original positions to their positions after the solar eclipse. And so I basically kept the well-oiled machine well-oiled, if you would allow that.
I will allow that. What impact did your project have on the physics community? I know it's a big question.
Okay, so this was probably one of the most groundbreaking experiments because it proved Einstein's theory of general relativity in the way that massive objects actually create gravitational fields that bend light around them. And this disproved Sir Isaac Newton's theory of regular gravitation, universal gravitation. And this was quite crazy in the world because this completely rewrote the physics books in things that people did not understand. And it was very intense. I think it was very important.
I'm sure it is and was. So last question. What unexpected factors did you and your crew have to deal with on the days of the experiment?
Well, we were so caught up in actually going and doing the experiment and breaking this ground for the physics community that we completely did not realize that we had factors that could, just absolutely mess everything up. The weather was a big one. We could have gotten there and the weather would just be trash. Like days before the experiment, we actually had lots of cloudy and foggy days, and we were all very nervous that we weren't going to get this clear vision of the solar eclipse that we all wanted. Thankfully, on that day, it was very beautiful and sunny. I'm pretty sure Arthur Eddington didn't have as good of weather as we did, so that's why we had two places. One of the other things that we had to deal with that we did not expect was the organization issue. We didn't realize that bringing all of these people together in two places at the same time was going to be a major feat of leadership and micromanaging, with people getting on this boat and getting here at this time and just getting everyone there and all the boats ready and the supplies and everything. It was a task in itself, I guess you could say. So those two were the major factors in this experiment.
But it seems like y'all handled it pretty well.
I think we did.
Okay, well, thank you, Mr. Crommelin. That concludes our interview. Thank you so much for your time, and it's been great to hear about your experiment.
Thank you, ma'am.